Hello and welcome back to CMIS310, Chapter 7. And I apologize it's taken me so long to get this out. Long time no talk, because literally I've not been able to talk. And as you can tell, my voice isn't quite back yet, but we're going to try this anyway, because I just don't want to get any further behind. So Chapter 7, I hope everybody saw the announcement on Blackboard about the mistake on the homework assignment, that it's not 6.1.3.5, but 6.13.5 is the last lab you need to do on test out. So normally in class I would ask you these questions, so you don't have to worry about me calling on you, but I do expect everybody to have a grasp of these sorts of questions that you'll see on an exam in terms of reviewing Chapter 6 material. So do take a look at these questions if these are pretty basic, so if you're uncomfortable with them, you might have to go back and do a little more studying, rereading of Chapter 6, talking to a classmate, talking to me, whatever we can do to help you out. So Chapter 7, remember I'm just doing kind of a consolidated version of Chapter 7 because it's all about I/O, input-output technology. And I kind of laugh at the objectives that say they're kind of use a lot of technical language, text and image representation. Well, to me, that's graphics. Video display devices, those are monitors. Printers, optical input devices, those are scanners. Audio I/O devices, those are sound cards. And then I want to get into some kind of more real-world issues that the textbook just doesn't get into. So there's our usual roadmap of where we're going. This was an interesting idea in the textbook. I never really thought about it so specifically that monitors and printers do share a lot in common in terms of how they handle characters, bitmaps, how they handle color, how they measure typefaces. Typically for resolution, we talk about DPI, dots per inch. Here's an example, 50 DPI versus 200 DPI. Obviously, whether you call this being bitmappy or stair-steppy, same thing. It's just a low-res version of the same thing. And so obviously we want our monitors and our printers to, the higher resolution the better. But of course there's a price to pay for higher resolution, which is taking up more memory. Fonts you should be familiar with already, and how fonts are measured in terms of points. So 12 point times Roman is kind of the default in Microsoft Word. There's an example of points. Back in the olden days, some software used points and some used pitch, points per inch, but now it's all points. Color is handled differently by monitors and printers. So when you see RGB, it's just referring to those three colors, red, green, blue. When you see CMY or CMYK, cyan, magenta, yellow, and black. If you've got a color printer, an inkjet color printer, I should say, you're probably familiar with this terminology already. But I wanted to add another one to the mix, which is Pantone. Pantone is a trademark name, but I ran into Pantone when I was supporting people that worked in a graphics department, graphics design, and they said it's a real problem for when they want the exact shade of red, not too orange, not too yellow, not too this, not too purpley, not it's just an exact. They want Pantone red 1152 or whatever the Pantone number is, and they said it's very hard to get either a monitor to display exactly what that color looks like. It'll get close, but it's not exact. Similarly, on the printer, it won't be exactly the same red, and they always found that frustrating. Me, I'm in IT, I can't tell the difference. Red is red. But they wanted a level of precision that most monitors and printers simply can't support unless they support something called Pantone coloring. So if you run into that in the workplace, that's what that means. So image storage, again, just talking about graphics here. There are a lot of graphics file types from GIF or GIF, whichever you're going to call it, JPEG, MPEG for movies. All of these are lossy. We talked about lossless versus lossy last time. You should remember that one, that lossy means you're losing some resolution in the compression. Before we leave dots per inch, I wanted to mention, how do you know how many is enough? If you've saved anything in PowerPoint, you notice you can change the DPI between 50, 200, 300 or more. 50 is going to be really terrible looking. 200 is normally plenty for screen and print. 300, when we talk about scanners later, when you start scanning things in at 300 DPI, it takes significantly more memory, and 600 DPI is huge. There are scanners that go up to 1200 DPI. There are printers that go up to 1200 DPI, but it's much, much more expensive. Something that I do in PowerPoint all the time to keep my PowerPoint slides small is if you highlight a picture and go up to the toolbar, up to the ribbon, and choose Compress Picture, it gives you some options for DPI, for how you save the image. And so I try to reduce it as much as possible just to keep my file sizes small. The problem with bitmaps is, well, they're bitmappy. So as you expand them, you're going to see that stair-stepped edge more and more. So what's better than a bitmap? Well, what's better than a bitmap is a vector image. A vector image is defined not by a bitmap, but by vectors, by lines and curves, so mathematical formula, so that a vector graphic, doesn't matter how big you draw it out, it's still going to be crisp and clean. All the edges are going to be clean. And then why the textbook combines PostScript and PDF together, I have no idea, because they're really separate issues. PostScript is something that, again, a graphics department is going to care about, because when they send a file to the print to an external printer, not the hardware printer, but the business of a print shop that's going to print something professionally, like on a glossy magazine, they have to have their the file type has to be PostScript for them to process in high resolution. PDF, on the other hand, is simply just a kind of lowest common denominator file type for sharing files in a read-only mode. So it converts your Word file, your Excel file, your anything type of file into a PDF. You should be familiar with this already. It was kind of revolutionary 20 years ago, but not anymore. I have problems with the ability of a PDF to give you complete authorial control, what's highlighted in red there, because really there's so many programs that can convert a PDF back into a Word file, which technically you're not supposed to be able to do. The PDF should be the final product. So when I don't want somebody to be able to copy my work, I put it in a PDF and I turn off the save and print feature and copy feature to lock it down. But even when you do that, there's still ways around it. So PDF doesn't do everything it's supposed to, but it's a very common format. So switching slightly from graphics over to video controllers, so we know what a bus does from the previous chapter, that the CPU has to talk to the video controller via a special bus. When we talk about video controllers, this is where we get into specific terminology around the refresh rate, how much video RAM you have, especially for gaming, or for certain engineering software like AutoCAD, you care about video RAM. Dual porting, if you're going to connect two monitors, dual monitors together, and then graphics accelerators or special graphics cards, again, typically for gaming. The video controller talks to the actual hardware device, the video monitor, and of course we've gone through several iterations of technology. Originally we were all using CRT monitors, the big bulky ones that you can get for $5 now at any Goodwill, and which sometimes I do. LCDs, I think I have yeah, I've got a picture on the next one of what an LCD looks like, and then plasma and LED is kind of newer technology. So LCD just looks like this, kind of like a calculator display. First generation laptops had LCD displays, but these are pretty rudimentary. Plasma displays look very nice, but they take a lot of power. So what's better than those? Well, LED displays are give you the high resolution of a plasma, but the low power consumption of an LCD. So typically, if you're buying a new display, it's going to be an LED type display. Now, what's on the back of that display in terms of the connector types on the back of your display? VGA, again, is a very old standard, lowest common denominator. DVI is a newer standard, although even that, some sites will tell you, is starting to become obsolete. HDMI, I would say, is getting very popular. Yeah, that's all I'm going to say about connector types there. Actually, what I do at home for dual monitor, I connect one monitor via DVI and the other monitor via HDMI. Just be aware that DVI does carry a digital signal, but it doesn't carry data or audio, whereas HDMI also carries audio, which is interesting. And you remember our friend, I keep showing his videos because he's crazy. He's nutty and wacky, and he talks too fast. But do check out this YouTube clip on your own. It's 5 minutes, but he goes into the kind of detail around video standards in a nice frenetic way, and that way he does. Again, just another example of how there are many different video resolutions over the years, from VGA on up. The book doesn't talk about projectors, but obviously that's another output device that we commonly connect via VGA, DVI, even HDMI, although typically it's through a VGA cable. And typically, for whatever reason, you have to stop down your resolution because the higher the resolution projector needs to display, it becomes much more expensive. So a lot of, if you're getting a projector, you can actually rent them for free from Lovejoy Library. FYI, I've done that. You typically have to change your resolution on your laptop that you're connecting to it before it'll display properly. Why? Just because. I did mention dual monitors. This is becoming more and more popular. There are a number of ways to do this. One is to have two separate graphic cards inside your your processor case. Another is there is like a DVI splitter you can buy. It's just one cable that has two outputs on it. Or you can do my version, which is just to use completely different ports, your DVI port and your HDMI port. Just different ways to skin it. So from video, we're switching over to printers now, and what I'm going to do is hit pause here and start a new video for the printer section. See you in a minute.